Section 3.8, explicit and implicit differentiations. Recall that differentiation means compute a derivative. So explicit differentiation means explicitly compute a derivative. Implicit differentiation means implicitly compute a derivative. The following example 1, will help you understand what is explicit differentiation and what is implicit differentiation. Example 1. Find an equation of the tangent line to the circle at this point. The graph of this equation is a circle. The circle is centered at the origin and has the radius 5. This point is a point on the circle. It is about here. At this point, there is a tangent line, and we need to write down the equation of the tangent line. To find the equation of the tangent line, we need to know the slope of the tangent line. To determine the slope of the tangent line, we need to compute derivative. To compute derivative, we need to know the function of this curve. Now, to get the function of this curve, we solve the equation for y. Y depends on x. Y is the function. Now, solve the circle equation for y. Move x squared to the right side, then we have this equation. Take square root on the both sides, then we have this equation. When we take square root, don't forget the plus and the minus sign in the front. So we have two functions. That is, the circle equation contains two functions. The graph of this function is the upper semicircle, and the graph of this function is the lower semicircle. Because this point is on the lower semicircle, to find the slope of this tangent line, we take derivative on this function. This function is not a product, not a function times another function. So we cannot use the product formula to compute the derivative of this function. This function is not a quotient either, not a function over another function. So we cannot use the quotient formula to compute the derivative of this function. To compute the derivative of this function, we can only use the chain rule. Net yield below 25 minus x squared. Then the function becomes just square root of u. Now we need to compute this derivative. Because x and u are different variables, before we can compute this derivative, we need to apply the chain rule. We insert du to the denominator and du to the numerator. Then this derivative is equal to the product of these two derivatives. Derivative of square root of u with respect to u by the power formula, it is 1/2 times square root of u. Now, remove u. Plug in 25 minus x squared in u, then we have this equation. This derivative, the function is a difference. So we can use the difference formula to compute this derivative. Derivative of constant 25 is 0. Derivative of x squared is 2x. Then we have this equation. Now cancel the number 2 and cancel the minus sign. Then we have this equation. This is the derivative of this function. After we get the derivative of the function, we can tell the slope of the tangent line at this point. Plug in the x-coordinate free of the point in the derivative. Then we get the slope of the tangent line at that point is 3/4. Now we have the slope. We have 1 point on the tangent line. The equation of the tangent line can be written down by the point slope formula. The result is here. Let me make a summary about this solution. To find the slope of a tangent line, we need to compute a derivative. To compute a derivative, we need to have a function. To have a function, we need to solve the given equation for the y variable because the y variable depends on x. Y is a function of x. It turns out that there is a second solution. In the second solution, to find the slope of a tangent line, we need to compute a derivative. To compute a derivative, we don't need a function. So we don't need to solve the given equation for the y variable. Now, let me present the second solution. To obtain the derivative, we don't need to solve the given equation for the y variable, then compute the derivative. Instead, we can adopt the solution here. Differentiate the both sides of the given equation. Take derivative on the left side, derivative on the right side. The derivative of left side is a sum of two functions. X squared depends on x, so it is a function of x. Y depends on x, so y squared depends on x. So y squared is a function of x. By summation formula, derivative of a sum is sum of the two derivatives. So we have this equation. Derivative on x squared with respect to x is computable by this formula. Derivative on y squared with respect to x, this derivative is not computable because y and x different. Before we can compute this derivative, we need to write it into a product of this derivative and this derivative. This step is the chain rule. We can cancel dy, and go back here. Now, derivative of x squared with respect to x by this formula, it is 2x. Derivative of y squared with respect to y by the same formula, it is 2y. Derivative of constant 5 squared is 0. So we have this equation. Now, divide the equation by 2. So we get this equation. Remember, we are looking for dy over dx. So we need to solve this equation for dy over dx. Move x to the right side, then we have this equation. Move y to the right hand side, then we have this equation. So derivative of y with respect to x is negative x over y. After we get the derivative, we can tell the slope of the tangent line at this point. Plug in the point in the derivative, namely, plug in the number 3 in x, negative 4 in y, then we get the slope is 3 over 4. Now, we have the slope of the tangent line, and also we have 1 point on the tangent line. But the point slope formula, the equation of the tangent line is this. Here are 2 remarks about example 1. From solution 1, we have derivative is x over square root of 25 minus x squared. From solution 2, we have derivative is negative x over y. Actually, these 2 derivatives are equal. How to see that? From solution 1, we saw that y is negative square root of 25 minus x squared. If we plug in this equation here, then the derivative from solution 2 becomes this. Cancel the minus sign, then we have this equation. This is the derivative from solution 1. Therefore, derivative from solution 2 is equal to the derivative from solution 1. Remark number 2. Solution 1 is called an explicit differentiation because to compute the derivative, we explicitly solve the given equation for the function y. After we get the function, then compute the derivative on the function. Solution 2 is called an implicit differentiation because we compute the derivative without explicitly solving the given equation for the function. Instead, we take derivative on the given equation to get the derivative. Example 2. Consider this equation. In this equation, x is an independent variable. Y is a variable that depends on x. When something depends on x, we say that that thing is a function of x. So y is a function of x. Now, part A. Solve the equation for the function y, then compute the derivative of the function. To solve the equation for y, move cosine to the right-hand side. Then take square on the both sides. Then we have y is 5 minus cosine square. Now, compute the derivative of the function. We can view the function as a product. 5 minus cosine times itself. So we can use the product formula to compute this derivative. But here, let me use the chain rule to compute the derivative. Let u below 5 minus cosine. Then the function becomes u squared. Now, we need to compute this derivative. In this derivative, u and x are different. So this derivative cannot be computed directly. We need to apply the chain rule. Insert du to the denominator and du to the numerator. Then this derivative is equal to this derivative times this derivative. Derivative of u squared with respect to u is 2u. Now remove u. Plug in 5 minus cosine in u. Then we have this equation. Now derivative on 5 minus cosine. Derivative of 5 is 0. Derivative of cosine is negative sign. Simplify this expression, then this is the result of the derivative of function y. Part B. Find the derivative of y by implicit differentiation. That is, don't solve the equation for y, then compute the derivative. Instead, take derivative on the equation to get the derivative. Now, take derivative on the both sides of the given equation. The derivative on the left-hand side is a sum. Cosine of x is a function. Y is a function because y depends on x. So square root of y is a function. Now, by the summation formula, this derivative is equal to derivative of cosine plus derivative of square root of y. Derivative of cosine with respect to x is computable. It is negative sign. But this derivative is not computable directly because y and x are two different variables. Before we can compute this derivative, we need to apply the chain rule. Insert dy to the denominator and dy to the numerator. If we cancel dy, then we can get back here. So, by the chain rule, this derivative is this derivative times this derivative. This derivative of square root of y with respect to y, we can use the power formula to compute it. Square root of y is y to 1/2, a power function. So this derivative is 1/2 times square root of y. Derivative of cosine is negative sign. Derivative of 5 is 0. Now, remember, we are looking for dy dx derivative on the function y. Now, solve this equation for dy dx. Move negative sign to the right-hand side. Then we have this equation. Move 2 times square root of y to the right-hand side. Then we have this equation. This is the result of derivative of y. Part C. Check that your solutions to part A and part B are consistent by substituting the expression for y into your solution in part B. From part A, we know that y is equal to 5 minus cosine square. Plug in this expression in the derivative obtained in part B. This is the derivative obtained in part B. Plug in the expression for y in the y here. Then we have this equation. Cancel the square root and the square. Then we have this equation. This is the derivative obtained in part A. So, derivative in part B is equal to the derivative obtained in part A. So the results in part A and part B are consistent. Example 3. Consider this equation. Part A, find the derivative explicitly. Part B, find the derivative implicitly. Part C, find the tangent line to the curve at this point. The graph of this equation is this curve. This curve is the set of all the points that satisfy the equation. Please note that this curve is the graph of an equation, but not the graph of a function. A function y is equal to f of x. One x value has only one y value. But this curve, one x value, there are two y values corresponding to it. Therefore, this curve is not the graph of a function. Now, solution to part A, find derivative explicitly. That means solve the equation for y, then we have a function. Then compute the derivative of the function. Since the given equation, this equation, is a polynomial in y with degree 4. The degree is 4. No formula is available to solve the given equation for y. If the polynomial is degree 2, we have a quadratic formula to find the root of this equation. If the degree is 3, we also have a formula to find the root of this equation. The formula is very complicated, but when the degree is 4 or higher, no formula is available for the root. So, to solve this equation for y, because the degree is 4, no formula is available. Therefore, explicit differentiation doesn't work. In other words, no solution to part A because we cannot solve the equation for y. Solution to part B. Take derivative on the left side and on the right side of the given equation. Then we have this equation. By the subtraction and summation formulas, we split the derivative on the left side into 3 derivatives. About the derivative in the middle, we can use the product formula to compute it because the function is a product of 2 functions. X squared depends on x, it is a function. Y depends on x, it is also a function. By the product formula, this derivative is equal to derivative of the first function, x squared, times the second function, y, plus the first function times derivative of the second function. About the third derivative, we cannot compute it directly because x and y are different. Before we can compute this derivative, we need the chain rule. By the chain rule, we can write this derivative as a product of this and this, these 2 derivatives. If we cancel dy, then this product will go back to this derivative. By the formula for power functions, derivative of x to the 4th is 4x to the 3rd. This one is 2x. Derivative of y is y prime. Derivative of y to the 4th with respect to y is 4y to the 3rd. Derivative of y is y prime. And this derivative is 0. Now solve this equation for y prime. Distribute the negative side to the 2 terms. Then we have this equation. Move the last 2 terms to the right hand side, then we have this equation. Factor out y prime, then we have this equation. Finally, move the factor x squared minus 4y to the 3rd to the left hand side, then we have this equation. This is the result to part B. Here is a remark about part B. The result of the derivative contains x and y. In this example, we cannot solve the given equation for y, so we don't know how y depends on x. Therefore, we cannot remove y from the result. We cannot express the result in terms of only x. So, containing x and y is the best answer to this example. Solution to part C. Find the tangent to the curve at this point. That means write down the equation of the tangent line to the curve at this point. In part B, we have found derivative. So we can tell the slope of the tangent line at this point. Just plug in this point into the derivative, then we can get the slope of the tangent line. The slope of the tangent line at this point is plug in the point in the derivative. Then we get the slope is 2/3. Now, about the tangent line, we have the slope, and we have one point on the tangent line. So, by the point slope formula, the equation of the tangent line is this. After we simplify this equation, then we get this. This is the answer to part C.